Hello and welcome to another video brought to you by RouTube. In this video, I will explore log scales, which students will be introduced to and study in Year 12 Further Maths. So just one learning objective from this video, and it's taken straight from the Further Maths study design, and it's to use a log with a base 10. So in this course, it's only going to be a log base 10. So use a log base 10 scale to display data ranging over several orders of magnitude and interpret powers of 10. All right, let's start by having a look at logs to the base 10. So like I said, in the further course, when we look at logs, they'll all be with a base of 10. Now, if you're doing methods or have used logs before, you'll know that you can deal with different bases, but like I said, in the further course, they are all going to be base 10. So the log of a number is the power of 10, which creates that number. So for example, we can see there log base 10 of 10 is equal to 1, log base 10 of 100 is equal to 2, log base 10 of 1000 is equal to 3, and so on. Okay, so what does that actually mean? Well, let's have a look here at this line I've just highlighted here. Let's have a look here. So we've got log, and then in a little subscript, we've got 10, and we write it as a subscript to refer to it as the base. So we can see that the base is 10. Then in the bracket, that's the number that needs to be logged. Okay, and we'll deal with that in a second. Then essentially what we need to do, we need to find the power to which we need to raise 10 to get to that number that we need to log. So essentially what we need to do is we need to raise 10 to the power of something to find 1000. And that's what the value of 3 is. So 10 to the power of 3 is equal to 1000. Okay, so the log is equal to 3. So log base 10 of 1000 is just asking you to find what 10 needs to be raised to the power of to give you 1000, which, as we can see, is 3. So log base 10 of 1000 is equal to 3. Now moving along, if a log of a number is given, so sometimes you'll actually be given the log value rather than needing to find the log. So you need to know sort of both processes. So if the log of a number is given, the number can be found by working backwards. So for example, if we're given this little question here, so log base 10 of x, so an unknown, is equal to 2. So we're being told what the log is. The log value is 2. We're obviously looking to solve to find x. What you can do is just ask yourself, if I raise 10 to the power of 2, what is going to be the value of x? So it's essentially just 10 times 10, and therefore we can see that the answer should be 100. So therefore the x value would be 100. Now if a number is greater than 1, its log to the base 10 is greater than 0. These are just sort of 3 little rules just to sort of remember. If the number is greater than 0 but less than 1, its log to the base 10 is going to be negative. And then if the number is 0, the log is going to be undefined. All right, so as always, it's great to do a lot of things in maths, but we sort of need to know why we use them and sort of the benefits. So why do we use logs and log scales? So when data involves values from multiple orders of magnitude, so for example, 1, 10, 100, 1000, and so on, it can be difficult to plot them on the same set of axes and still be able to see the distribution clearly. Using a log transformation on the x-axis provides an appropriate scale such that the data sets with multiple orders of magnitude can be properly compared. The histograms below represent the same data with the right histogram represented using a logarithmic scale or a log scale. So, as said, both histograms represent the same piece of information or the same data. You can clearly see in the left histogram, all of the data is over here. That's because this little piece of data here, it's sort of giving us no indication of comparing any of the data. Okay, so there's not a lot of information that we can get from that left histogram because the order of magnitude is so large. Then we look at the right histogram. Once again, the same piece of data. We've now got a log scale, and we can see that it's a log scale because on the x-axis it's got log of x. Okay, now we can clearly get a much better representation of the data, and we can then sort of answer some follow-up questions based on specific values between specific numbers and so on. So we get a much better representation of the data. Even though it's the same data, using a log scale can give us an indication and be able to see distribution clearly, or much clearer than without a log scale when we have values from multiple orders of magnitude. So let's interpret and read the log scale. So I'm just copied and pasted the log scale histogram from the previous part we went through, and we're going to have a bit of a look at that. So when a log scale is used, the data is much more evenly spread along the scale, like we saw from the previous example. When reading a log scale, it's important to remember that log 10 is equal to 1, log of 100 is equal to 2, log of 1,000 is equal to 3, and so on. So essentially what that means is, where we have the 1, this value is just 10 to the power of 1. This value is just 10 to the power of 2. This value is 10 to the power of 3, 10 to the power of 4, 10 to the power of 5, 10 to the power of 6, and I've also forgotten 10 to the power of 0. So the log values are just 10 to the power of whatever that value is. So here we'll just write it 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, 10 to the power of 4, 10 to the power of 5, and 10 to the power of 6. Okay, that is always how it's going to be in the further course, because they are all log base 10. So then now I've just sort of taken 3 things that we can sort of see hopefully from the histogram. We'll go through these now. There is one value below 10. Okay, so if we have a look and try and identify where 10 is, and I might do it with the green, 10 is just 10 to the power of 1, because 10 to the power of 1 is just 10. So therefore, any value that's less than that to the left of that, there's only one value here. So there's only one value that's below 10 in this data distribution. There are 5 values between 10 and 100. Well, between 10 and 100, we have 10 is 10 to the power of 1, and 100 is 10 to the power of 2. So therefore, that's 1, and that's 4. So that's how we can see that there are 5 values between 10 and 100. And then there are 3 values above 1,000. So 1,000 is 10 to the power of 3, which is just here in green. I've just highlighted here. So we've got 1 value, 2 values, and 3 values that are above 1,000. Now, a really common question is to be asked how many data values there are between certain values. Okay, that's a really common SAC and exam question. So the most important thing is that you know on a log scale, it's just 10 to the power of that number, because it's always a log base 10. All right, let's have a go at calculating log values on the CAS. So here we go, calculate the log value of 4,000 correct to 2 decimal places. So what this is essentially asking you for is 10 to the power of what equals 4,000. That's what you need to sort of figure out here, or that's what the CAS is going to help you figure out. So if you can sort of think about it, 10 to the power of 1 is 10, 10 to the power of 2 is 100, 10 to the power of 3 is 1,000, 10 to the power of 4 will be 10,000. So the log value of 4,000 is going to be between 3 and 4, because 10 to the power of 3 is 1,000, 10 to the power of 4 is 10,000. So it's going to be 3 point something. But obviously we need to find the correct answer, and that's where we call on the CAS calculator. So to activate the log function, you'll see log just written here in blue. To activate any of the blue functions on the calculator, just press the control button and then press on the button. So we know it's always log base 10, and then in that bracket there, we're just going to put 4,000. So once again, that's just going to work out 10 to the power of something equals 4,000, and there we have it. So it's between 3 and 4, like I said, and then we round to 2 decimal places. So we look at the second digit and then the third digit. The third digit's below 5, so therefore the second digit remains as it is. So the correct answer, the log value should be 3.60. All right, now let's use the CAS to help us find the number when we're given the log. So like I said before, sometimes you'll be given the log and then you'll have to sort of work backwards to find the actual value. So if the log of a number is 2.6, find the number correct to one decimal place. So we'll round to one decimal place when we find our answer. So there's two ways we can do this. What we can do, we can use the solve function. Okay, so we can use the algebra solve function. So we can just type in solve or hit menu algebra solve. And then what we can do is, like we spoke about before, log base 10. Now we don't know what the actual value is. We know the log value, but we don't know what the actual number is. So we're just going to put an X. You can put any variable in there. I'm just going to put X. Now we know what the log value is. We know that it should be 2.6. We know that it's 2.6. So essentially what it's asking you for, if you raise 10 to the power of 2.6, what does that value give you? And we know whenever we use the solve function, we always need to then solve by using the comma X or comma Y or comma whatever you label it as the variable. Okay, so then we can press enter and there's our value. Okay, so that's one way of doing it. The easier way, I think, is because we know that it's always log base 10, essentially, like I said before, it's just 10 to the power of 2.6 equals that X value. So we can just put in here 10 to the power of 2.6, and you'll see we get the same answer as we used above using the solve function. So both ways are totally fine, and you'll always get the same answer because we're always dealing with log base 10. Okay, so same answer both ways, doesn't matter which way you use, as long as you get the right answer, that's obviously the main thing. And then we need to round correctly to one decimal place. So the correct answer should be 398.1. All right, so now we're going to have a go at constructing histograms, both regular histograms and ones with log scales on the CAS calculator. So the weights of 27 animals in kilograms were recorded below, and then we've got all the measurements, and we can clearly see they come from multiple orders of magnitude. We've got 0.12, and then we've got 87,000 kilograms. So probably an ant and an elephant or something like that. So we'll see in a second that the histogram provided will probably not be able to give us a whole lot of information, but we'll have a look at that in a second. So our job is to construct a histogram to display the distribution of the body weights of these 27 animals and then the log body weight. So we've got to create two different histograms on the CAS. So as always, just to save us a bit of time, I have already entered the data values in. So if we scroll all the way down, you'll see that bottom cell should be 27, number 27, because we have 27 animals. So first thing is we need to create just a basic histogram, which hopefully we all know how to do. So we go to our data and stats page, and this is all of our information we've put in. As always, give your column a heading. In this case, it is called weight. And we see our dot plot created. And then to create a histogram, it is just menu, plot type, and then histogram. And we can see there our histogram, there's our answer to part A, and we can clearly see it does not give us a fantastic distribution there because there is sort of multiple orders of magnitude. We can see this 87,000 value here, and then so many values that are on the left-hand side here. So there's our answer to part A. Now we're going to go back to our lists and spreadsheets. Here we go. Now, what we need to do in the second column, what we're going to do, we're just going to create another heading. I'm just going to call it log W, okay? We can call it log weight. We can label it as anything you like, or we can call it L weight for log weight. Doesn't matter what you call it, as long as you give it a heading. So in this little cell here, this is where we need to put essentially our formula to find all the log values of all the weights. So we're going to hit Control
and then log base 10. Now we want to find the log values of all of the weight, all of the values in the weight column. So that's why I'm going to type in weight, and then we can just press enter. Now you'll most likely be prompted and it'll say either column reference or variable reference. Always go with variable reference. So here we have all our log values. All of our log values. Now if we might go to a different page, our data and stats page again. Now instead of putting on our axes weight, we're now going to put L weight, which is our new histogram, the new values, and then once again menu, plot type, and histogram, and we can see we have a much nicer histogram, one that gives us a little bit more to talk about and a little bit more information in terms of the distribution. Now you'll see in terms of starting weight and alignment, you can move those so where the histogram starts. Don't worry too much about that because you'll be sort of prompted in the question what they want the starting point and the bin width to be. Just sort of take from this little part of how to actually find the log values and then to plot them, and then you can answer questions from there. So we have found the histogram of the body weights of the 27 animals, and then also the log body weights, which is this histogram here. So if we go between 1.2, 1.4, there's our original histogram. With the same piece of data, we go to 1.3, and there's our log scale histogram. And we can see on the x-axis, we've got 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, and so on. Okay, so we've got both our histograms drawn, and you can simply just draw them on your paper.
As always, thanks so much for tuning in to another video brought to you by RouTube. If you learned a thing or two about log scales, or you just want to give us a like and a subscribe, please do so, and I'll catch you next time.